In this lecture, we will discuss about how to write a program, I mean 8051 program to add two 16-bit numbers. Okay, so let us take two numbers as FA10 and other number as ABFE. If we add these two numbers, we get the result as 1A616. So this result is more than 16 bit. Okay. So when we use the 8051, the 8051 cannot perform on 16-bit numbers at once. Okay. Because 8051 is a 8-bit microcontroller, it can perform on only 8-bit data. Okay, so now we'll see how the microcontroller does addition of the 16-bit numbers. So first it will take, so this is D. Okay, so first it will take lower byte number, that is lower byte of the first 16-bit number and the lower byte of the second 16-bit number, and then it will add. So the result we get is 116. Okay, and this will be present in accumulator. Okay, so after adding these 8-bit numbers, and next same process will continue, it will take FA and then higher byte of the second number and the carry generated in the first addition. Carry generated in the first 8-bit addition, and then we get the result is 1A6. Okay, so this is how the 8051 performs the 16-bit operation. Okay, so now let us write the program. Okay, right. So before that, we'll assume where the data we want to store. Okay, so we'll assume that we'll store the first lower byte result in 40H and the next higher byte result in 41H and the next result in 42. Okay, so in many ways we can write the programs, that is any of the addressing mode we can use when we write the program. Okay, so in this one, first I'll take this first lower byte in R0 register and then other lower byte of the second number in accumulate. Okay, so to load the data in R0, we have to use the instruction move R0, ash 1DH. Okay, right? And next is done with move A, ash 0FEH. 0, 0. This I will take it as FF. Okay, FF. Here also I will take this as FF. F. Okay, FF H. So then we have a instruction to do the addition is add A, R. Okay, so this instruction will add 1DH along with the 0FFH and the result will be stored in accumulator. The result will be stored in the accumulator, that is 1C, and then the carry will be stored in the carry flag. The carry will be stored in the carry flag. Okay, so now next we will store, because for the arithmetic operation one of the data must be present in the accumulator. So for that reason we will store the lower byte result in 40H location, and that is done by the instruction move 40H, 40H, A So if I consider this is the memory location, internal memory location, and this is 40H, so the data will store here, that is 1C. So this is 41H and this is 42. Okay, so now next we need to add these two numbers. Okay, so now when we do this addition, we have to consider the carry also. If we don't consider, then the result will be wrong. For that purpose, the 8051 provides the instruction, it is add C. So add C will add the two numbers along with the carry. Okay, so we can do now add C. So before that we have to take this data, right? That is move R1 comma hash 0FAH, and then the other data in move A comma hash 0ABH. Okay, so now we'll use the instruction add C A comma R1. So now when we do this instruction, the result will be stored in accumulator, that is A6. A6. But carry is present in the carry flag. So that also we need to store. For that purpose, we need to check the carry flag. Okay. So for that, we can use the instruction JC. So JC instruction will check the carry flag, whether the carry is generated or not. If the carry is generated, then we have to store that carry in 42H. So what we can do is, I will write just here. I'll write this here next. So in the binary addition, the carry is nothing but only 1. So what I'll do, I'll move 42H, comma, hash 01. Move, next, move 42H, comma, hash 01. Okay, right? And then we will store the content of accumulator in 41H. That is the next higher byte of the result. That is move 41H, comma. So if the carry is not generated, then we no need to store the carry. Means the 42 in 42H we must have only 00H. So for that reason, to skip this instruction, we'll use the instruction sgem next, or sgem skip. Okay, we'll skip this one and we'll directly come to skip. Okay, so when you do this time, that time the 42H will remains 00H and next 10. Okay, so this is how we can do the 16-bit addition using 8051 microcontroller. Let's execute this program with the help of the key compiler. So I have already downloaded the program in the key compiler. Now we'll run this. Okay. So now the R0 is loaded with the lower byte of the first number, and the accumulator is loaded with the lower byte of the second number. Then using the add instruction, the contents of A and the contents of R0 is added, and the result will be stored in the accumulator, and that result will be stored in the 40H location. So that we'll see step by step. See, R0 is loaded with 1D, accumulator is loaded with FF, then accumulator is having the result of the 01DH and FFH, and then this result is stored in 40H memory location, right? So next, similarly, now R1 is loaded with the higher byte of the first number, accumulator is loaded with the higher byte of the second number. See, R1 is loaded with the higher byte of the first number and the accumulator is loaded with the higher byte of the second number. Then using the add C instruction, we are adding contents of R1, contents of accumulator along with the carry generated in the previous addition, and the finally result is stored in accumulator. The result is stored in accumulator is A6. Then we are checking for the carry, if the carry is generated or not. So if the carry is generated, then we are storing that carry in the 42H. So in this case, the carry is generated. So now the controller executes move 42H, add 01H because the carry is generated, and that will be stored in the 42H. Right. So now the result of the second byte addition will be stored in 41H. Yes. So now in 41H, A6 is stored. So the answer is, it is 1A616. So first lower byte is stored, and next higher byte is stored, and then next higher byte, most higher byte is stored. So the while we are reading, we have to read from the MSB, that is 1A61C.